Hi all, this is Lavanya. I am studying MSc Computer Science second year first semester in RBBRR Women's College. Today I am going to explain about encapsulating security payload. Now we will see what is encapsulating security payload. Before going to discuss about encapsulating security payload, we have to know about IP security architecture. IP security architecture is nothing but Internet Protocol security architecture that is provide to maintain the security to the traffic. In IP security, in IP security, there are two protocols, ESP protocol and AH protocol. ESP means encapsulating security payload. Encapsulating security payload is a protocol within the Internet Protocol security designed to provide a range security of services for the data packets as they travel across the network. ESP primarily focus on ensuring the confidentiality, integrity, and authentication of data being transmitted over a networks. Key characteristics and functions of ESP: confidentiality, integrity, authentication, encapsulation, flexibility, and security associations. Later, we will see the ESP format. This is the ESP format, encapsulating security format. In that, we have security parameter index. Security parameter index is nothing but unique number or identification. Next, sequence number. Sequence number means our entire message is divided into different packets. For each packet, we are given a number. For each packet, we have to give a number, and that number is nothing but sequence number. Payload data is nothing but original data. Padding means if we have a block of size 100 bytes and the block is filled with 99 bits. Now we can add one more byte to the block. That is nothing but padding. Pad length means how many number of bytes we are added to that padding. That is nothing but pad length. Next header means next block. Next integrity check value. This is the top level format of the ESP packet. Now we'll see detailed security parameter index. Security parameter index is 32 bits, identifies the security associations. Next, sequence number in monotonically increasing the counter value. This provides an anti-replay function. Next, payload data. This is the transport level segment, transport mode, or IP packet and or tunnel mode that is protected by encryption. Next, padding. Padding is we can add the data to the block. If the block is not filled with that size, now we can add the data to the block. Next, header. Text header means identify the type of data contained in the payload data field by identifying the first header in the payload. An extension header in IPv6 or an upper layer protocol such as TCP. Next, pad length indicates the number of pad bytes immediately preceded this field. Next, integrating check value, a variable length field that contains the integrity check value computed over the ESP packet minutes that authentication data field. Now we will see in ESP encapsulating security payload, we have two versions, IP4 version and IP6 version. Now we will see both the versions. Before applying the ESP, both the IP4 version and IPv6 version are this is the original IPv4. Now we'll see the format of the IPv4, original IP header, TCP and data. And IPv6, original IP header, extension header, TCP and data. Before applying ESP, these are the versions IPv4 and IPv6. Now encapsulating security payload have two modes, transport mode and tunnel mode. Now we are adding the ESP to the IPv4 version and IPv6 version. That is transport mode. We are adding the original ID header and ESP header to the IPv4 version. That is, now this is original IP header, ESP header, TCP, data, ESP tiler and ESP authentication. TCP, data, ESP tiler or the encrypted. Now IPv6. Original ID header, hope by hope, dist, routing, segmentation, ESP header, best, TCP, data, ESP trailer, ESP authentication. This is the transport mode. This is the first mode of the ESP. We can now in that we are adding the other components to the IPv4 version. And here we are adding extra blocks to the IPv6 version. Now we will see tunnel mode. In that new IP header, ESP header, versional IP header, TCP data, ESP trailer, ESP authentication. This is the IPv4 version with the tunnel mode. Now we will see IPv6 version with tunnel mode. New IP header, extension header, ESP header, original IP, extension header, and TCP data, ESP trailer, and ESP authentication. This is the tunnel mode. That means in overall, ESP has two versions, IPv4 version and IPv6 version. We can add the IPv4 version and IPv6 version to the ESP. Now we have two modes, transport mode and tunnel mode. When we are adding ESP to the IPv4 version and IPv6 version, we can generate two modes. That is nothing but transport mode and tunnel mode. Here we see what is transport mode and tunnel mode. This is complete the ESP format. Thank you.